The morning of September 7th, 1942, Labor Day. Along the banks of the Ohio River in Pittsburgh, Pennsylvania, thousands of workers, families, and curious onlookers climbed trees, stood on rooftops, and crowded the shoreline. They weren't there for a holiday picnic. They were there to witness something that shouldn't have been possible: the launching of a 328-foot warship 2,000 miles inland from the nearest ocean. The massive vessel, designated simply as LST-1, sat poised at the edge of a greased launchway at the Dravo Corporation's Neville Island shipyard. Attached to its upper deck, a simple sign: "Forward to Victory, America." When the restraining blocks were knocked away, the ship began its slide toward the water. The crowd erupted in cheers and whistles. The wake it created was so enormous that spectators along the riverbank scrambled to higher ground to avoid getting soaked. This wasn't just any ship. This was the United States Navy's very first landing ship, tank the first of a revolutionary fleet that would make the invasion of Europe possible. And it had been built not by traditional naval shipbuilders with centuries of experience, but by a company that specialized in constructing barges and bridges. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This is the story of how civilian engineers outsmarted the Navy's own experts, how assembly line techniques borrowed from automobile factories transformed warship production, and how a radical reimagining of what was possible turned an impossible deadline into a production miracle that changed the course of World War II. It's a story about the moment when the old guard of traditional shipbuilding met the new reality of American industrial might and discovered that everything they thought they knew about building ships was about to be proven obsolete. The problem began on December 7th, 1941. When Japanese aircraft struck Pearl Harbor, they didn't just destroy battleships and aircraft. They revealed a fundamental strategic reality that would define the entire Pacific War and eventually the liberation of Europe. Victory would require amphibious assaults, massive ones. The ability to carry tanks, trucks, artillery, and thousands of troops across oceans and deposit them directly onto hostile beaches, often under fire, without the luxury of ports or piers. The British had learned this lesson the hard way at Dunkirk in 1940. Their evacuation from France had been a near disaster, accomplished only through a desperate flotilla of civilian boats. Prime Minister Winston Churchill understood that any return to the continent would require purpose-built ships capable of what he called shore-to-shore delivery, not ship-to-dock, not transport to tender, but ocean-crossing vessels that could sail right up onto a beach, open their bows, and disgorge tanks directly onto enemy sand. The British Admiralty had experimented with conversions, taking 3 shallow-draft tankers built for Venezuela's Lake Maracaibo and retrofitting them with bow doors and ramps. These makeshift landing ships proved the concept worked, but their bluff bows made them slow and inefficient. What was needed was an entirely new design, purpose-built from the keel up. At the Atlantic Conference in August 1941, 4 months before Pearl Harbor, President Franklin Roosevelt and Prime Minister Churchill discussed this precise problem. The Americans agreed to take on the design and production challenge. Within weeks, a small British delegation arrived in Washington to meet with the U.S. Navy's Bureau of Ships. The man who would solve the design problem was John Niedermeyer, a naval architect working for the Bureau of Ships. In November 1941, Niedermeyer sketched out an awkward-looking vessel that seemed to violate every principle of traditional ship design. It needed a flat bottom for beaching but enough draft for ocean crossings. It required massive cargo capacity but had to fit through river locks for inland construction. It needed bow doors that could withstand ocean swells but open quickly under fire. Niedermeyer's solution was elegantly simple: ballast tanks. The ship would take on water for stability during ocean passage, drawing 14 feet aft. Then, approaching a landing beach, it would pump out the ballast, reducing its draft to less than 4 feet forward. The bow would incorporate large clamshell doors opening to a 14-foot width, with a ramp that could lower directly onto sand or rock. The preliminary plans called for a vessel 280 feet long, By January 1942, this had grown to 290 feet. Within a month, the final specifications stretched it to 328 feet longer than a football field with a 50-foot beam, and the capacity to carry 20 Sherman tanks, or 2,100 tons of cargo, plus 163 troops. The British immediately requested 200 of these vessels under Lend-Lease. The Americans planned hundreds more for their own use. On paper, the LST looked like the answer to every amphibious commander's prayers. There was just one problem. Nobody knew how to build them fast enough. Traditional shipbuilding was a methodical, time-intensive craft. Each vessel was essentially custom-built, with workers riveting thousands of individual plates and frames together over months of careful construction. The major coastal shipyards, Newport News, Bethlehem Steel, the Brooklyn Navy Yard, were already overwhelmed with contracts for destroyers, cruisers, battleships, and aircraft carriers. They were working at capacity, and their methods simply couldn't scale to produce hundreds of LSTs in the time frame the war demanded. Initial estimates suggested it would take 6 months to build a single LST using conventional techniques. But the invasion of Europe, what would eventually become Operation Overlord, the D-Day landings, was tentatively planned for mid-1943, then 1944 at the latest. The Pacific Island hopping campaign couldn't wait either. General Douglas MacArthur and Admiral Chester Nimitz needed these ships now, not years from now. The Navy Bureau of Ships faced a dilemma. Coastal shipyards couldn't handle the volume. But there was another option, unconventional and risky: America's inland waterways. Along the Ohio, Mississippi, and Illinois rivers sat dozens of companies with experience building barges, towboats, and rivercraft. They understood welding, prefabrication, and modular construction. They had access to America's steel heartland, and they weren't bogged down with existing Navy contracts. There was just one catch. None of them had ever built an ocean-going warship. Exactly 1 month after Pearl Harbor, in early January 1942, 2 men received an urgent telephone call in Pittsburgh. J. D. Berg, chairman of the Dravo Corporation, and V. B. Edwards, the company's president, was summoned to Washington for immediate discussions with Admiral S. M. Robinson, chief of the Navy Bureau of Ships. Dravo Corporation had been around since 1891, founded by brothers Frank and Ralph Dravo, both Lehigh University graduates with degrees in mechanical engineering and metallurgy. The company had made its reputation building barges, towboats, and river equipment for the Ohio and Mississippi river systems. They constructed locks and dams. They fabricated steel sections for bridges. They understood heavy industrial production and river transport, but they had never built anything remotely resembling a Navy warship. Admiral Robinson laid out the problem with characteristic naval directness. The Navy had a design for the LST. They had an urgent need for hundreds of them. Traditional shipyards couldn't produce them fast enough using conventional methods. The Navy needed someone who could think differently, who could apply industrial mass production techniques to shipbuilding. Robinson came armed with a preliminary design, a massive purchase order, and a question: could Dravo do it? Berg and Edwards returned to Pittsburgh and gathered their engineers. The technical challenges were staggering. An LST was more than 6 times longer than anything they'd ever built. It required sophisticated diesel engines, complex ballast systems, bow doors that had to be both watertight and rapidly deployable, and electrical systems far more advanced than anything on a river barge. It would need to be built to naval specifications, inspected to naval standards, and capable of crossing oceans in conditions that would sink a conventional river craft. But as Berg and Edwards studied the design, they began to see something the traditional shipbuilders had missed. The LST, for all its size and complexity, was fundamentally a box, a very large, very sophisticated box, but a box nonetheless. It didn't require the complex curves of a cruiser's hull or the precision engineering of a destroyer's turbine systems. It was, in essence, a massive steel container with a flat bottom, a bow door, and engines. This was something that could be built the way you'd build a bridge in sections, using prefabrication, with modular components that could be manufactured separately and then assembled. The company accepted the Navy's proposal. Dravo would serve as the lead yard for LST production, responsible not just for building ships themselves, but for pioneering the techniques that other inland yards could adopt. They committed to a $195 million shipbuilding program and a $24 million plant expansion. 4 other inland river builders would be brought into the program: American Bridge Company in Ambridge, Pennsylvania; Chicago Bridge and Iron Company in Seneca, Illinois; Jeffersonville Boat and Machine Company in Jeffersonville, Indiana; and Missouri Valley Bridge and Iron Company in Evansville, Indiana. Dravo would function as design agent, procurement coordinator, and technical trainer. These 5 companies, working cooperatively, would aim to produce the ships the Navy desperately needed. The goal seemed impossible: to design a production system, build or expand shipyards, train workers, and begin delivering completed LSTs within 11 months. Ground was broken at Dravo's Neville Island facility 27 days after receiving the assignment. There was no fanfare, no ceremony, just engineers with blueprints and construction crews with bulldozers. The existing Neville Island plant, which employed between 1,000 and 1,500 workers in peacetime, was designated the West Yard and immediately expanded. Half a mile away, a 66-acre riverside field was purchased and transformed into the 2 East Yard. Simultaneously, Dravo's smaller assembly facility in Wilmington, Delaware, which had previously been used for final assembly of harborcraft, was converted into a full-scale LST production yard. The workforce expansion was breathtaking. Within months, Dravo's payroll swelled from 1,500 workers to more than 16,000 at Neville Island alone. By early 1944, the combined workforce at Pittsburgh and Wilmington would exceed 26,000. These weren't experienced shipwrights. They were filling station attendants, musicians, lawyers, beauty operators, factory workers, and farmers. Roughly 16% were women, many of whom became skilled welders, operating alongside men on all-women crews. Office buildings sprouted across the yards. Dispensaries, cafeterias, locker rooms, and vast parking lots had to be constructed to support this industrial army. A sign over the main gate at Neville Island reminded everyone of the stakes. We can, we will, we must. Training became its own massive undertaking. Traditional shipbuilding apprenticeships took years. Dravo had weeks. They developed accelerated training programs focused on specific tasks: welding, riveting, electrical work, engine installation, pipe fitting. Workers were cross-trained to move between stations. Supervisors were created from the ranks of those who learned fastest. The key innovation was Dravo's decision to treat LST construction like an assembly line rather than traditional ship construction. Instead of building each ship from keel to deck in a single location, Dravo broke the LST down into massive prefabricated sections. These sections would be manufactured at 5 separate area steel plants, then transported to Neville Island for final assembly. Each section was enormous, in some cases weighing dozens of tons, but manageable with the heavy cranes and equipment Dravo already possessed for bridge construction. The tank deck, the bow doors, the engine room, the crew quarters. All could be built as discrete modules, with internal welding and fitting completed before the sections ever reached the final assemblyways. This meant work could proceed simultaneously on multiple sections of multiple ships, with specialized crews becoming highly efficient at their specific tasks. Electric welding replaced traditional riveting almost entirely. This was faster, created stronger joints, and required less skill to learn proficiently. It was also perfect for training new workers quickly. A competent welder could be trained in weeks. A skilled riveter took months or years. The production line plan worked like this. Prefabricated sections would arrive at the assemblyways. Giant cranes would lift them into position. Welding crews would join the sections together. Electricians, pipe fitters, and mechanics would complete the connections between modules. The ballast system would be tested. The diesel engines supplied directly by the Navy to ensure. Standardization would be installed and tested. Finally, the completed hull would be painted, the bow doors fitted, and the ship launched. From launch, the LST would move to the outfitting dock, a half-mile stretch along the Ohio River where final fitting out occurred. Navigation equipment, weapons, typically 8 40mm and 12 20mm anti-aircraft guns, communication systems, and crew supplies would be installed. Sea trials would be conducted as far inland as possible. Then the ship would begin its journey down the Ohio River toward the Mississippi, bound for the Gulf of Mexico and final fitting out at coastal naval bases. This journey itself presented challenges. The Ohio River featured numerous bridges with clearances designed for barges, not 328-foot warships standing 6 stories tall. The Navy established a ferry command of specially trained crews to navigate these vessels through the river system, working with local authorities to modify or temporarily alter bridges as needed. Some bridges had to be raised. Others required the LSTs to time their passage for low water conditions, but the system worked. On September 7, 1942, less than 8 months after Admiral Robinson's initial meeting with Berg and Edwards' LST, one slid down the ways at Neville Island. It was the Navy's first LST, period. Not just Dravo's first, but the very first of what would become a fleet of over 1,000 vessels. The assembled crowd witnessed more than just a ship launch. They witnessed proof that American industrial capacity could adapt, innovate, and deliver at a speed that would have seemed impossible a year earlier. In 11 months, Dravo had transformed from a river barge company into the lead producer of the Navy's most critical amphibious assault ship. They had designed a production system, built shipyards, trained thousands of workers, filled a supply pipeline with thousands of components, and delivered a completed, seaworthy warship. And they were just getting started. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The initial production schedule called for Dravo to complete 1 LST every 6 points one day. By October 1942, standardization protocols were formalized and production began to accelerate. 23 LSTs were in service by the end of 1942, but the Navy's appetite for these vessels was insatiable, and the demands of global war were accelerating. By 1943, construction time had been reduced to 4 months, from keel laying to commissioning. This was already a dramatic improvement over traditional shipbuilding timelines, but it still wasn't fast enough. The planned invasion of Sicily, Operation Husky, required LSTs. The subsequent Italian campaign would need more, and looming over everything was the massive undertaking of invading France itself. Dravo's engineers continued refining their processes. Material procurement became more efficient as the Material Coordinating Agency, an adjunct of the Bureau of Ships, ensured that the numerous builders in the program weren't bidding against each other for steel plates, engines, electrical components, and the more than 30,000 parts that went into each LST. This centralized procurement system eliminated delays and allowed construction schedules to accelerate. The breakthrough came through relentless attention to detail. Every bottleneck in the production process was identified and eliminated. Welding crews developed specialized techniques for joining the massive prefabricated sections more quickly without sacrificing strength. The layout of the assemblyways was reconfigured to minimize the distance materials had to travel. Crane operators became so skilled they could position a multi-ton hull section with precision in a single lift. Training programs evolved. New workers learned not just from instructors but from those who'd been on the job for a few months, which, in Dravo's accelerated timeline, made them veterans. Knowledge spreads through the workforce organically. A welder who discovered a faster way to complete a particular seam would share that technique with others on the shift. Supervisors who identified ways to streamline handoffs between work crews would implement those changes immediately. The modular construction approach proved its worth repeatedly. Because major sections were built simultaneously at different locations, any given LST was actually under construction across 5 or 6 different facilities at once. The tank deck might be taking shape at one steel plant while the bow assembly was being fabricated at another and the engine room fitted out at a third. When these sections came together at Neville Island, the ship was already perhaps 60 or 70% complete by the end of 1943. Dravo had achieved something remarkable. They could complete an LST in approximately 2 months from start to finish. This wasn't just faster than traditional shipbuilding, it was faster than most people thought possible for a vessel of this size and complexity. The other inland yards, using Dravo's techniques and benefiting from Dravo's training and procurement coordination, achieved similar speeds. The 5 inland yards working together, Dravo, American Bridge, Chicago Bridge and Iron, Jeffersonville Boat and Machine, and Missouri Valley Bridge and Iron would ultimately produce 724 LSTs, representing 68% of the Navy's entire LST fleet. The success of these cornfield shipyards, as they came to be called, was a revelation to the established coastal builders. It demonstrated that traditional methods weren't sacred, that industrial innovation could transform even something as ancient as shipbuilding, and that American manufacturing capacity, properly organized and motivated, could accomplish what seemed impossible. Then came the ultimate test. In early April 1944, Secretary of the Navy James Forrestal contacted Dravo's management with an urgent request. Operation Overlord, the invasion of Normandy, was scheduled for early June. The landing plans required more LSTs than were currently available. Specifically, the Navy needed 15 additional LSTs delivered by the end of May. That gave Dravo less than 8 weeks to produce 15 ocean-going warships. Under normal production schedules, even at Dravo's improved pace, this would be impossible. 15 ships in 8 weeks meant completing 1 LST every 3.5 days. Not from keel to launch, that was just the beginning. From keel laying through launch, fitting out, testing, and delivery to the Navy ready for combat operations, every 3.5 days. Berg and Edwards called a meeting of their supervisors and foremen. They laid out the challenge. The fate of the invasion, the liberation of Europe, might hinge on whether Dravo could deliver these ships on time. The workers needed to understand what was at stake. The program was designated the Hot Ship Initiative. Production schedules were torn up and rebuilt from scratch. The yards would operate with overlapping shifts, 24 hours a day, 7 days a week. Every available worker would be mobilized. Every crane, every welding station, every work area would be in constant use. Material deliveries would be coordinated to the hour. The Navy agreed to prioritize engine deliveries and other government-furnished equipment. What followed was a display of industrial determination that rivaled anything happening on the battlefield. Workers put in 12-hour shifts, then stayed for extra hours when critical tasks needed completion. Welding crews worked through the night, their torches creating a constant constellation of sparks along the riverfront. Supervisors coordinated the movement of materials and workers with the precision of a military operation, which, in effect, it was. The prefabrication system proved its ultimate worth during the hot ship program. Because so much work could be done simultaneously at multiple locations, the traditional serial bottlenecks of shipbuilding were bypassed. While 1 LST was being assembled on the ways, sections for 3 others were being fabricated off-site. The moment one ship launched, the next set of sections was ready to be lifted into place. Women welders, who had proven themselves as capable as their male counterparts, worked alongside men in integrated crews. Many of these women had never held a welding torch before 1942. Now they were helping build warships under impossible deadlines and doing it with skill and precision. The pace was exhausting. Workers grabbed meals in cafeterias, operating around the clock. The medical dispensaries treated minor injuries, without work stoppages. Everything was subordinated to the single goal: 15 LSTs by May 31st. The first of the hot ships was completed in early April, then another, and another. The rhythm accelerated. Launch ceremonies, which had been major events attended by thousands during LST-1's debut, became almost routine. A ship would slide down the ways, and even before the wake had settled, workers were positioning the first sections of the next vessel. On May 29, 1944, 2 days ahead of the deadline, the 15th hot ship was completed and turned over to the Navy. Dravo had produced 15 ocean-going LSTs in less than 8 weeks. One completed vessel every 3.5 days. It was a manufacturing achievement that would have been dismissed as fantasy before the war. These weren't inferior ships rushed through production with corners cut. They were fully capable LSTs, built to the same specifications as those produced at the normal pace, inspected to the same standards, and ready for combat operations. Several of these hot ships would participate in the Normandy invasion itself. The human cost of this achievement often goes unmentioned in official histories. Workers suffered exhaustion, injuries from the relentless pace, and the strain of knowing that any mistake, a faulty weld, a misaligned section, a flawed installation could cost lives when these ships hit the beaches. But they also felt the pride of knowing they were part of something larger than themselves, that their work mattered in the most direct and immediate way possible. On June 6, 1944, Operation Overlord began. 173 LSTs participated in the Normandy landings, the largest amphibious assault in human history. Among them were dozens built at Dravo and the other inland yards. Some carried the British 50th Infantry Division to Gold Beach. Others transported American units to Omaha and Utah. Still others served as floating supply depots, shuttling ammunition, fuel, vehicles, and reinforcements from England to the expanding beachhead. LSTs proved critical in ways the initial planners hadn't fully anticipated. When a severe storm destroyed the American Mulberry Artificial Harbor on June 19th, the LSTs became the primary means of landing supplies and reinforcements. Their ability to beach themselves directly meant they weren't dependent on functioning ports or piers. They could drive right up onto the sand, drop their bow ramps, and begin unloading even under fire. Jim Knox, a 25-year-old sailor from Emsworth, Pennsylvania, just miles from where these ships were built, served on LST 491 at Normandy. Decades later, he would describe standing on the bridge of his ship, watching the great battleships bombarding the French coast while the sky turned black with aircraft. His LST had been part of a convoy of 36 that crossed the English Channel on June 5th, loaded to capacity, with troops, tanks, jeeps, and equipment. The ungainly vessels that crews had sarcastically nicknamed large, slow targets proved far tougher than anyone expected. Despite being valuable targets carrying enormous amounts of men and material, only 26 LSTs were lost to enemy action during the entire war. Their flat-bottomed hulls absorbed tremendous punishment. They survived groundings, artillery fire, and kamikaze attacks. They became known to the troops as beach angels for their ability to deliver desperately needed supplies and evacuate wounded soldiers. In the Pacific, LSTs were equally crucial. General Douglas MacArthur's island-hopping campaign relied on them entirely. From Guadalcanal to the Philippines, LSTs carried the Marines and Army units that seized Japanese-held islands. Admiral Chester Nimitz's Central Pacific Offensive used them at Tarawa, Saipan, Iwo Jima, and Okinawa. More than 340 LSTs supported the Okinawa invasion alone. The psychological impact on Japanese defenders was significant. They had been told American forces were soft, that American industry was weak, that American resolve would crumble under determined resistance. Then they watched LST after LST emerge from the sea, each one disgorging 20 tanks, dozens of vehicles, and hundreds of troops. The sheer scale of material, the endless supply of equipment, ammunition, food, and reinforcements contradicted everything they'd been promised about American capabilities. One Japanese officer, captured on Saipan, later described watching the American landing fleet with a sense of hopelessness. He had been assured that American production was exaggerated, that Japan's warrior spirit would overcome American material advantages. But standing on the beach, watching what seemed like an infinite number of ships deliver an infinite amount of equipment, he realized the war was already lost. The Americans didn't just have more. They had so much more that Japanese resistance, no matter how fierce, couldn't matter in the end. This was the strategic impact of Dravo's innovation amplified across a global war. Each LST represented not just a ship, but a multiplication of American power. The ability to deliver tanks, trucks, artillery, and supplies directly onto hostile beaches meant American forces could establish beachheads faster, reinforce them more quickly, and sustain offensives longer than any enemy could counter. The LST became a symbol of American industrial might, in a way few other weapon systems did. Battleships and aircraft carriers were impressive, but they took years to build and required traditional naval expertise. LSTs were proof that American industry could take an urgent need, apply innovative thinking, train unskilled workers in weeks, and produce thousands of complex machines in a time frame that seemed impossible. Allied commanders understood this. General Dwight Eisenhower, Supreme Commander of Allied forces in Europe, wrote multiple letters to General George Marshall, emphasizing the critical importance of LST production. The shortage of LSTs delayed the invasion of France by a month from May to June 1944 because there simply weren't enough available to support simultaneous landings in Normandy and southern France. That one extra month of production, including Dravo's hot ship program, made the difference. The irony wasn't lost on Navy traditionalists. The vessels that proved most critical to winning the war weren't designed by seasoned naval architects in established shipyards. They were refined and mass-produced by bridge builders and barge manufacturers in Pittsburgh and Evansville, by workers who had never seen an ocean, using techniques borrowed from automobile assembly lines. The old guard of shipbuilding had been shown that their centuries of accumulated expertise, while valuable, wasn't sufficient for the scale and speed modern war demanded. Dravo's workforce peaked at over 26,000 employees across their Pittsburgh and Wilmington facilities. By the war's end, they had produced 145 LSTs, plus 20 subchasers and minesweepers, 27 destroyer escorts, 65 LSMs, landing ship, medium, and numerous other vessels. Their total World War II production contracts exceeded $500 million, an enormous sum for a company that had employed 1,500 people building river barges just 4 years earlier. The transformation of these workers mirrored the transformation of American industry itself. Filling station attendants became shipwrights. Beauty operators became welders. Musicians and lawyers and farmers became part of an industrial army that produced weapons of war at a scale and speed unprecedented in human history. They worked under a sign that read, "We can, we will, we must," and they did. On March 5, 1942, Dravo became the very first corporation to receive the Army-Navy E Award for outstanding wartime production. This was before they'd even delivered LST-1, based solely on their rapid conversion to war production and early progress. It was a recognition not just of what they'd accomplished, but of what they represented. American industrial capacity unleashed, American ingenuity applied to seemingly impossible challenges, American workers rising to meet demands that would have broken lesser nations. The workers themselves rarely spoke in such grand terms. For them, it was a job that needed doing. They were proud of their work, certainly. They knew the ships they built were saving lives and winning battles, but most simply came to work each day, did their jobs with increasing skill, and went home exhausted. The heroism was in the aggregate 16,000 people, each doing their part, combining to achieve something no individual could have accomplished alone. After the war ended, the massive LST fleet became partially surplus. Many were scrapped, others were converted for commercial use, their revolutionary design inspiring the modern roll-on, roll-off ferry industry. Some were sold to foreign governments under military aid programs. A few remained in U.S. Navy service through the Korean War and even Vietnam. But the lessons of LST production, the demonstration that traditional methods could be replaced by innovative approaches, that impossible deadlines could be met through systematic planning and workforce training, that civilian industry could match or exceed military expertise, these lessons resonated far beyond World War II. They influenced how America approached the Cold War, the space race, and subsequent military conflicts. They became part of the national narrative about American capability and industrial strength. Today, only 2 World War II-era LSTs survive as museum ships. LST-325 is maintained in working condition at Evansville, Indiana, built by Missouri Valley Bridge and Iron Company, one of the inland yards that used Dravo's techniques. It's a floating reminder of what was accomplished along those inland rivers, thousands of miles from any ocean. The story of the LST is often overshadowed by more glamorous weapons, the P-51 Mustang, the M4 Sherman tank, the B-17 bomber. These get the attention, the movies, the mythology. But military historians and veterans know the truth. Without LSTs, there would have been no D-Day landing at Normandy, no island-hopping campaign in the Pacific, no way to bring American industrial might to bear on the beaches where the war would ultimately be won. The profound irony at the heart of this story is that the most critical vessel for projecting American power across oceans was designed by the Navy but perfected by barge builders. The expertise that made victory possible came not from the established centers of shipbuilding excellence, but from the industrial heartland, from companies and workers who had never built anything like an LST before and who succeeded, precisely because they weren't bound by traditional assumptions about how ships had to be built. J. D. Berg and V. B. Edwards, receiving that phone call in January 1942, could have reasonably declined the Navy's request. They could have explained that Dravo lacked the expertise, that the timeline was impossible, that traditional shipbuilders were better suited for such a critical contract. Instead, they saw an opportunity to apply industrial principles to a naval problem. They saw a box, a very sophisticated box, but fundamentally a box that could be built the way you'd build a bridge. That insight, combined with the determination of thousands of workers who learned new skills at impossible speed, changed the course of the war. When those workers stood along the Ohio River on September 7, 1942, watching LST-1 slide down the ways and create a wake that sent spectators scrambling, they were witnessing more than a ship launch. They were witnessing proof that American industry, American innovation, and American determination could accomplish what had seemed impossible less than a year earlier. The LST represented the collision of old and new traditional naval power meeting modern industrial production. The traditional methods, careful and time-tested, couldn't deliver what the war required. The new approach, radical and unproven, succeeded beyond anyone's expectations. 1 LST every 3.5 days during the hot ship program, 15 ocean-going warships in 8 weeks, 724 LSTs from 5 inland yards that had never built ocean-going vessels before the war. This wasn't just about ships. It was about what becomes possible when urgent necessity meets innovative thinking, when established limitations are questioned rather than accepted, when thousands of ordinary people are given the tools, training, and purpose to achieve extraordinary things. It was about the moment America's industrial capacity stopped being theoretical and became devastatingly real, a reality that every Axis soldier who watched LST after LST disgorge tanks and troops onto hostile beaches came to understand with terrible clarity. The workers at Dravo didn't set out to revolutionize naval warfare or rewrite the rules of shipbuilding. They set out to build the ships the Navy needed as fast as humanly possible. The revolution happened because they succeeded. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.